Good afternoon. I'm Simon from Limegreen, and I'll try and tell you a little bit about us and why we think, in particular, lime plasters and renders and that sort of thing make for a healthier building. So we've been selling lime plasters and mortars for a little while. We have sold them to all sorts of buildings, from ecological buildings to old buildings, and all sorts of stuff. So we supply insulation systems using natural insulation. We firmly believe in natural insulation for its ecological benefits and its moisture buffering and other important things. But we've also supplied a lot of mortar to more traditional railway stations and that sort of thing as well. So a variety of projects. This is a little bit about us. Our new factory, where we produce all our new lime mortars and lime plasters, it's about a year old, and it's the culmination of a number of years of working hard to in development and in building it. So we've already heard this, I'm sure you'll probably hear it again, about the amount of time we spend inside and what that can do to us. Indoor air quality, emissions, moisture, sound and thermal comfort are all really, really important for the occupants' health and well-being. I've kind of got two contrasting pictures there. The guy with the wheelbarrow is doing a lime concrete floor, but for some reason they've tanked the walls with plastic. So I think it's not one of our projects, but it seems a slightly peculiar thing to do to me. If you're using lime plaster, I think covering the walls in plastic at the same time might not be necessarily in keeping with it. On the other picture behind it is a development we're involved with quite a number of years ago, where every aspect of the 15, 20 houses was considered, from the natural paints, the plaster, the recycled bricks, natural insulation. So it's a very well considered project. So I'm not pretending I've got particular answers to any of these questions, but these are some of the things where I see where it can affect the indoor air quality. In particular, children can be sensitive, or are certainly more sensitive to air quality as they're developing. And in fact, in other countries such as Germany, kindergartens and things like that have regulations on indoor quality and the types of paints that can be used. Adhesives, so VOCs can be dangerous, and come in different forms, come from different places. So adhesives, carpets, paints, obviously. Fire retardants is something's in the press at the moment. Something that's perhaps radon, obviously, and then there's other things which we introduce ourselves. So perhaps from cooking, that might be depending on what you're cooking on. Maybe what's it giving off. Humidity is a very important thing, and that's something we can help with in terms of lime plasters and clay plasters as well. But increasingly, all those are affected by the drive for greater air tightness and versus ventilation we've got there. The bottom picture's a building not far from us in Shropshire. Don't know if you can see it, but it's a medieval whole house and is as drafty as it could be. So I bet the indoor air quality there is probably just the same as it is outside. We think it's important product choice. So we get involved in projects where people have considered the products very carefully. Like the previous slides we were looking at. That there's a variety of things out there, and if it was me, I think I'd be asking questions about them, about what's in the product, what's it made from, how is it produced, that sort of thing. As I said before, we like natural installations. We make a number of plaster and render systems that work with those. And those plaster and render systems are designed to work with the natural installations, so you enhance the benefit of them. One of the big benefits is moisture buffering. So to improve the indoor air quality, control of moisture and is really important. Lime and clay plasters and lime and clay paints and those sort of things can help control that, which means that if the humidity is kept at a careful level or the correct level, this reduces other knock-on effects, such as dust mites and things like that, like damp, moist, humid conditions. Dust mites have been found to increase asthma in children and that sort of thing. So as I say, we produce lime and lime plaster and that sort of thing, and they control the moisture. But not all lime plasters have to be used in a sort of the top right-hand picture, the straw bale building. We also get involved in lots of buildings where people want more contemporary look, and they still benefit from there. One of the big benefits of lime in particular is that it's higher alkalinity. The higher alkalinity of the plaster means that there is less chance of mold growth. So I think I've forgotten to include it in my slides, but I've got some nice slides of mold growth on different plasters and at different times. It might not be that exciting, but it is to me. If you don't have to finish lime plaster with synthetic paints. There are increasing range of natural paints and lime paint, of course. And again, the lime paint has high alkalinity, which helps with mold growth, helps buffer moisture. The natural paints increasingly declare their ingredients. So if you're allergic to something or if you want to avoid something, that's something you can look out for on the label. And I wanted to add this a little bit at the end. In addition to how we produce the lime plasters, there are ways in which increasingly there are ways in which you can add stuff to a lime plaster, or any plaster actually, which might improve its indoor air quality properties. So they can be in the form of catalysts, so you can get photocatalytic minerals and pigments. You can get these are very, very small particles. Effectively, they're sieves. They can capture things like VOCs and stuff like that. So you can put them in there and they can capture it. And then externally and internally, but we don't do that because remember the lime is alkaline, you can add chemicals such as biocides. The catalysts are mineral and they react with VOCs and things like that in the air. The catalyst isn't broken down but uses light to break down the pollution to smaller particles. The problem with that is we don't currently do this, but you can buy products with this in. What is it breaking it down into? Is it breaking it down to something that's harmless, or is it breaking it down to just smaller and smaller different compounds? The capturing technology, I forgot to get off. Okay, I'm nearly finished. Literally does that, captures stuff from the air. That could be smells, or it could be pollutants. And biocides, we just don't really get into those because, like I say, the lime has a natural alkalinity which can kill mold and that sort of stuff. And that's it.